This is JF, and I suck at ATS. Let's just write hello world. Easiest possible program. I don't quite suck at ATS enough that this is going to be hard, but we'll get there. We'll get to me having lots of problems very shortly, I'm sure. I'm going to make a make file. There you go. Hello world. It works. That was easy. I didn't have any weird errors, nothing. That works totally fine. Now let's... yeah, I remember one of the first C programs I wrote. I think it was Hello World, but it accepted some flags and it did things a little bit differently. So, like, obviously, Hello World is not a very useful program, but it'd be much more useful if you could put out, if you had options on what kind of output to produce. So let's do that. Just start with the previous program. So this is there are two big header files that people load into ATS. This is sort of the minimal one. This is the ATS preload, and then there's all static load stuff and hats for the header files for ATS, share, that stuff. The other one is very similar to this. I think it's pre-install lib ATS or ATS lib ml.hats. We'll just see if that works real quick. And we're not going to be clever at all with our make file. We're just going to create a new target for each new source. Hello. Because we should be a little bit clever. Oops. Alright. Hello world. Okay, so if that works, that probably means that's actually the right path. For a while, I had like a macro to add this automatically. Okay, yeah. I think it's way by path. So, I suck at ATS. Hello one.dats. One thing you also notice, if you're at all like wanting to be secretive, is that ATS also includes the path and symbols it makes. So, for example, temp, ATS, post ATS, source, paths, error, like. The file that produced this error had that path in the file system of like wherever it came from. That's a little bit weird. But you can change that. Okay. So for a while I had like a macro that would add these automatically, but I usually don't use the ML stuff, so I want to kind of roll my own to understand it better. And ML is a much higher level. That it has a lot of there's a lot of high level constructs that comes with that. It's also a little bit slower to compile, but it's noticeable in this machine. Anyway, so share, it's not particular to your project, it's shared. ATS preload, these are static stuff as opposed to dynamic stuff. And then you have the two libraries you can load. That had nothing to do with making Hello World. So back to Hello World. I want to have variations, I want to have options. So, one thing I can do, this is something actually suggested by a C book that I'm reading called, it's like C in the 21st Century or something like 21st Century C, I think. It points out that environment variables are a key value store that you get for free that's very easy to use and like low effort in the program. Like you don't need to do anything to use the environment store. Or you don't even have to set up for the environment store, just use it. So the key store that you get from environment variables. So, for example, rather than passing flags and then having to interpret flags and say, okay, this flag is a key and then it has this value and so on, and do all that parsing, or loading get options, having to do it for you, or loading some other library. You just use getinv. That's right in there. So getinv should be actually included. Let's see. Args. I'm not sure how this will work. Let's say It's traditional. We're gonna we're gonna call this the modern version. It's hello with a comma and a world and exclamation mark. We're gonna have a simpler one that's like the more traditional output for a program like this. And it's gonna be trad, and if that's gonna be like. Alright, so that environment variable exists, and it's equal to the string yes, then print hello world. What's it going to do that? Does it make? Alright, okay. getMGC is probably supplied by ML. I think it's in one of the files you can load directly, but okay. We're just not going to use that then. Just going to go ahead and use C's. Parsing error? External. Oh, I'm going to say this is some kind of function. One segmentation fault. Okay. Yes. ATS gives you tools that allow you to be super secure, and it gives you to make a lot of. It allows you to have a lot of compile time guarantees in your program, but it also allows you to not have them and to like get like C style seg faults. So. Let's see, trad equals no, okay, in that case it does nothing. Trad equals yes, in case it prints out the traditional one. That's not quite what I want. What I can do is I can say hello world, and if there's anything else, we'll use this old one. I keep hitting Control-R because I'm used to not using makefiles for like small stuff like this. But we're going to use a makefile. It's so much easier. Alright, segmentation fault, but trad equals no, we get the modern one, we say trad equals yes, we get the new one. So that works. The only problem is that it requires you to include that because we're doing string comparison right here, and getenv doesn't necessarily return a string. It always returns a pointer, but there may be stuff at the pointer or maybe a null pointer. And if you're confused by why I'm talking about pointers when I'm talking about strings, let's set that aside. Let's say that strings are pointers. If you have data, if you're working with a computer in the 21st century and you have data, then your data is either a number with you can fit in like a small number of bits. It's either some kind of number directly, or it's an address, and then you go through the address to get it, sequences of bytes that represent other stuff. And strings in all programming languages are usually passed around as addresses. Maybe addresses are like, I think in Forth you actually pass around two stuff. It's like you pass around the address and the length. In most languages, you pass around an address, and the address might have a length associated with it. Like, if you go to the address plus one integer-sized space, you'll find the length of the string, and then the other one is the string, another pointer to the string, or something like that. It varies, but the point is, getenv returns an address. That address is either null, meaning that there's no valid string to return. And you shouldn't dereference that because it points to like memory that isn't valid. So the segmentation fault is literally you tried to look at an address that you're not allowed to look at, even though like the 0, there's probably technically stuff there. It's like going to be kernel stuff, and we're not allowed to look at it. Okay, moving past all of that. So the point is we're doing a string comparison, something that might not technically be a string. So, but I'm saying it's a string right here. So this is a lie. One thing we do is we can stop lying, and we can say actually we can use myGetEnv, and myGetEnv it'll either return a string or it'll return like nothing. So we have a default. Oh, that's an idea. How about getenv default takes two strings and returns a string, and it's called, yeah, we usually leave it that because if you don't provide a name, then it uses the name you get. Before we were using something in C, and now we're still going to use something in C, but we're going to just write it ourselves. Okay. We're going to be technically correct and compare with null. So if getenv returns null, then we will return default. Otherwise, we return the value we got back from getenv. And this is not ATS right here. This is straight C programming language, which happened in the middle of our ATS program. And ATS knows it by this type and name and so on. All right, so now we're going to say getenv default. No, trad. Oh, sorry. So the key is trad, and the default value is no. Now we still, people could still pass anything, so we're still going to leave it like this. Although, actually no, we're going to do this. Hold on. I clearly have some errors here. Carry default. What's the problem there? Why does it not see expected expression? Is there something wrong with the word default? It seems to have to be the case. Or this. Yeah, it doesn't like default. It's gotta be a macro or something. Alright, so hello world. Normally it's, you get the modern version. If you say trad equals yes, then you get that. If you say trad equals no, you get the modern version again. If you trad equals, some garbage, then you get a compile, you get a runtime error. It says, hey, this line, so this line in the generated code and this line in the actual ATS code at this offset, you tried to do something and it was wrong. Or that offset, I believe it's taking tabs as one character. So the way I'm using hard tabs here, it's kind of, it gets a little bit confused by that. Alright. So this minus sign is saying, don't make it a compile time error what I'm doing here. So what I'm doing here is I'm very clearly not matching every possible string. I'm only matching two strings. But I'm not saying that, I'm not telling ATS that this thing can only be these two strings. I'm saying this returns a string. This is right up here. Getenv default, it returns a string. Well, a string can have anything at it, not necessarily this stuff. So I'll just go ahead and show that real quick. So yeah, this pattern match is not exhaustive. It should have an underbar in this case. If I say negative, I'm just saying, make that a runtime error instead of a compile time error. I'm going to trust that if somebody gives me trad, that it's either going to be one of these, and if it's not, just throw an error. They deserve an error. They're passing me garbage. All right. So this is a hello world. It's a little bit more useful. We've got two options in output. It's not using normally you'd want to have like something like this, but hello one trad. Normally you want something like that, but this works. Yeah, it's valid. It's useful. And the benefit is that you don't have to separate. You don't have to do any kind of setup for it, as stated perhaps too exhaustively earlier. You just get that with getenv. And we're not using getenv. Well, the focus here is hello world. Let's go ahead and show off just another version of this getenv stuff. Dots. Let's start with that. Okay, so instead of getenv default, we have to pass it default. Let's say we'd rather have getInv opt. You pass a string, and it says, you know, it gives you an optional string. What's it called? Optional 0 string. That's not really used to doing this, huh? Well, we can say instead of having the interface like yes or no, just if you set that variable, if you set that environment variable at all, then I'll assume you want trad, and otherwise, if you don't set that environment variable, you'll use the modern version. Now you can actually write getInv opt in C. You can create this optional 0 data type in C, but that's a little bit messy, and I'd have to look up how to do it. So we're actually going to write this in ATS again. Let's get rid of that. You don't need to have it separated like this either. Like you could just say, I'll go and do that for this. So fun getInv opt. Alright. So we're going to use getInv. Oh, that means we have to do this again. Extern fun getInv. We can do this as well. It's exactly the same as what I had before, just a little bit differently expressed. Before I was giving like a function type, and now I'm just giving the individual types of the components of the function, which is there's the same information there. So ATS lets you do it either way, whatever's more comfortable for you. All right, so we still have C's line getInv. Lies because this might not be a string that you can look at and do string comparisons of. It might be null instead. Okay. Let's have a val is null, just for the flag, and say I think I can just do this. The null pointer. I think the default ATS include provides that. Otherwise, I'd probably have to cast it and compare it against 0 or something like that. Right, let's not have that instead. Okay, so R equals the null pointer. Do it. If is null, then we return sum. The zeros here are just because this isn't a refined option type. It's like an unrefined option type, which means we can't do sort of dependent type analysis on it. It's kind of an odd thing, but you'll get used to it. So if null, then just go ahead and return sum, and the actual return. Sorry, actually no. If null, then we want to return none. So we didn't get a return from that. Else, I'm going to use kind of ML style, or like Occam's recommended style for just like these kind of expressions. So use else in the previous line and then start the new line. If there's like an if else, then say is if again, would be another case of it. Anyway, if null, then that. Otherwise, let's go ahead and return the actual return value. Let's say we can't really use val here. Key val. Just leave it as R. It's fine. It's return from getInv, even though it's kind of an awkward variable name. Okay, so output main we say is trad getInv opt. We know we're providing a default, and then it's going to be something. If you try to set it all to any value, even no value, which is possible, but it's a blank string, then we'll do the traditional way. Otherwise, if it's not set, we'll do the modern way. Makefile. Again, I'm not being clever here, so I'm not having it like auto-discover these tiny, standalone files, but you can do that. Let's just go ahead and do that. This is gonna for this episode. We're gonna do this. And I don't remember. There's a construct I can use here. I think it's like wildcard star.dats substar.dats like that. Okay, it's not quite what I wanted. That must be wrong then. Let's look at the man page real quick. It's gotta be info, and I don't have info files in the system. Great. Does it show? Alright, forget it. Hello 0, hello 1, hello 2. Really to be this clever. Clean, get rid of all that, rebuild them all. Alright. Clearly I messed up on the syntax there. Yeah. So unlike Awkml, unlike I think ML in general, no, it's Awkml. Awkml has let in and then an expression. It could be as long as you want. And in ATS, you have let in, and then you can have as many expressions as you want, and then you have to have an end. It's slightly different, and I think it's a little bit more awkward. But okay, none. Because it wasn't actually defined. All right, we'll do it myself. Data type optional of some type. Some unbox type because we're boxing them in this structure. So data type optional of T. I don't want to do it that way. Yeah, I think this is fine. Or rather, sum of T. Then none. I have to change how everything's called. We're not using 0 anymore. Although I could, since for the same reason. Oh, I hate this. Alright. Line 3, I did something wrong. This isn't the right syntax then. Yeah, remember, the title of the series is not JF explains how things work. It's JF sucks at ATS. Alright, so I don't remember how this works. I'll go to another screen and go look at some of my stuff in one of my other files. A grep data type, startup, that's how did I do that? Seriously, how did I do that? I'm still looking for something that's not. Oh, there we go. So that's the actual path of the file. Alright, I guess I can do this in this screen. So I'm looking for something I do often is I just grab the ATS source for stuff. So there's actually a file called option 0. So not optional. That's probably one mistake there. Alright. And there's indeed all ML stuff. Let's implement. So let's look at these statics. So option, some refinement cas. What? seems to be assuming it's already there. But surely you have... No, you don't. There's no data type definitions here. Damn it. Oh, that's what I was just looking at. It's probably actually normal then. It's probably in basis instead. Okay. So data type, and then okay. So I'm not interested. It's in parentheses. This is not like a variable name, and it's just a type. So okay. So you get a type. Hold on. It's gotta be some kind of name for it. Okay, yeah. It's like a function. Okay, so the T is type. So T. That should be fine. What did I do wrong? Oh, I dropped that. Now I'm doing a string comparison. Where am I doing that? Line 12? Let's say R equals the null pointer. And what it's saying about this is bool type. Okay, so basically this fails completely. One thing that's a little bit irritating with ATS is it's hard to query it. Like, clearly the null pointer is a real thing because it's not complaining about it. But, hold on. It's probably not a string, which is why it's not letting me do that. Oh, can use string to pointer or something like that. Let's just do a cast to pointer from R. So I'm going to cast to pointer and then compare it against the null pointer. No, it's not. Okay, let's cast it to an int and compare it against 0. There you go. What the hell? Ints? You can't find any... Oh, jeez. Okay, this is probably actually fine from the beginning, from the get-go. The problem is I'm doing a double equal sign here, and that's not ATS. ATS is you just use a single equal sign. Even though it's using it like it's using it here like for assignment. It's also over here for just equality. Okay, so the null pointer. I probably can just do that. No, it doesn't like that either. Now it's definitely saying you can't compare these two things. What are you doing? Okay, that works. This actually works. This is a good outcome. The problem is, the reason I'm getting this the error. So the error is saying it got to C, and then C complained and said, "Wait a second, like there's symbols here that I didn't understand." The problem is, when I create this data type here, these data types have to be freed. So there's some kind of like, there's memory management that's required. Because like, if you're gonna like this right here, this is a type constructor. So if you do none right here, you're allocating memory. Doing some right here, you're allocating memory, and you're assigning part of the allocated memory to R. So there's memory allocations that needs to be cleaned up. So and since you see like I'm not actually explicitly handling it anywhere, I'm not. This code could look very similar to how actually. Okay. Let me first fix this by just using a garbage collector. So ATS is not normally garbage collected, but if you're going to use data types, you have to deal with the memory somehow. One of those ways is let's just garbage collect it. Okay. So that means go to the Makefile, and see now I've got to create like a special one for it. I think there's a reason I should have done that. Alright, so what is it? memalloc. No. GCPW. Alright, that's correct. So now I'm using the Boehm GC garbage collector. and that'll just take care of any kind of data types that I create over the course of the program. Hello world, and if I say trad, if I set that to anything, I set it even to please not trad. There it is. It's traditional with no comma or anything like that. All right, so let's do that a different way. Different ways. We're not going to use garbage collector. Instead, we know that we create these and then pretty much immediately assume them, immediately consume them. So I'm going to call this a data view type instead. I'm going to call it optional VT, just so it's clear what's going on. I'm just going to go through and rename everything. And now we're going to rename everything. We're also going to add these symbols right here, which means the allocation part is the same when you create these, but since it's a view type, it's a linear type. So it needs to be consumed at some point. And these are saying yes, we're consuming it. So ATS will take care of freeing the memory at this point, and then instead of using a garbage collector, we can just use just normal libc, like malloc and free. So there's still memory allocation, which is kind of, using memory allocation at all is kind of dumb in this case, because you're just testing an environment variable. Like there shouldn't be any memory allocation actually required for the tasks we're doing, but whatever. Memory allocation is pretty normal, even if it's a little bit wasted. What about my hello 3? Alright, so optional VT, that's right, I changed that. I changed that to VT. Whoops. We don't need to link in the garbage collector anymore. Alright, hello 3. Trad, then it's trad. Alright, so in this case we have a getenv that returns an optional type. So it's either like none for the key one wasn't there, or it's some for here's the value that you asked for. And it's using, this is actually C's get or libc's getenv, the same one you use in C. We're just using it directly. We're saying it's extern, it's provided from the environment. And then this part right here is locking down the name. We're saying actually it's provided by the environment, and the environment calls it getenv. So it's when ATS generates C code, the C code is going to call getenv, and then the linker will take care of finding it in libc and doing all that. And then to determine if and getenv it lies, it's like we're lying actually. We say getenv returns a string, but it doesn't. It returns something that might be null or a string. So we test that here with an unsafe cast. Since we're lying, we have to sort of be a little bit unsafe to recover from the lie. You say it's null if this pointer is actually the null pointer. I wonder if what I tried to do would work here. Yeah, that also works. If you're a C pedant, then you might excuse me, you might not like that. You might be, hey, wait a second, null might not necessarily be the address 0, but obviously it's always going to be, unless like computer architectures change or something. Even then, we'd probably still use it. Okay. All right, but there's other things we might want to do. We might not want to just have, not just have like 2 variants of hello world. Let's add a feature. So another variable. I would say is color. So color flag. Just say it's color. So getenv opt. This one's going to be color. So if it's colorful, we want to do some other things. And what we can do is we can just work off a tuple. So if is trad is color, the linearity here might cause some problems. I wonder if it will. No, I just need to be exhaustive, and I want to be exhaustive anyway. So, okay. Remember again, this is called I suck at ATS. So even though like it seems like I'm able to put programs together and they sort of work, like no, this is very bad. This is all horrible. All right. We really could just have a getEnv. Let's do that. So fun has flag or flag set is flag set is flag set. So return a bool. So this is, I come from kind of like a little background, so this kind of aggravates me a little bit. Like now we're allocating something and then immediately deallocating it. Like this is calling getEnv and getEnv a little bit of memory allocation puts stuff into little containers, and then we're taking these containers, we're throwing them away immediately. I wonder if tuples would get around that, like because ATS has a syntax for box tuples and unboxed tuples. I wonder if you return a box tuple if that's actually efficient. Well, anyway. So this flag set, getEnv. Let me just say, flag sets. Actually, let's drop this entirely. So we have true is potential returns, false, and then of course true, false, and false, true. If we miss any of these cases, since this is not going to be a normal case without the minus sign, ATS would complain at compile time. In fact, we're gonna ensure that. I think it actually warns the compile time. But now it will definitely throw an error at compile time because we're saying like right here the plus no this is exhaustive. This should be exhaustive. Okay. So if trad is false and color is false, then just you do a normal modern hello world. But what about if we want a colorful modern hello world? Okay. These are ANSI escape codes. I'm gonna make it bold. This will look weird in my terminal otherwise. J33. The backslash 033 is escape, ASCII escape, and ASCII escape greater than, and then numbers that end, or like semicolon separated numbers that end in M is a code that sets colors. So 31 is red, 3 for foreground, 1 for red, and the 1 by itself is bold. So we're setting, and then over here, actually we don't want that. We want 0 for drop any kind of coloring. So the it's escape that is like this is a terminal. This is an ASCII escape code, and then our ANSI escape code, I think people call it. And then the M is this is a color, and then the actual codes there are tell you which colors. So obviously, anybody who does anything with computers should just memorize all of those, like I have. You could use a library, of course. It would be a little bit more irritating to do that in ATS because ATS doesn't have this feature. It doesn't add strings to each other. It doesn't concatenate strings that are right next to each other. So if I had like hello world here and then like define red like this, like define FG red like that. And if I said FG red hello world like like this, like FG red hello world null. This is something we can do in C. It's in some other languages. I think usually other languages you have like explicit concatenation. But so you do this in C, then it's actually completely there's no extra strings built at runtime or anything. It's like this is all just turns into one string and it's compiled that way. But ATS doesn't have that, unfortunately. I think that's it's not something that C is often praised for, but it actually is like a useful feature, especially for like formatting long lines and stuff like that. Okay, so if we want trad and color, then actually we don't want that. We want to go and swap these. Okay, so if you want traditional but still colorful output, then you'll print out hello world with red. If you want a traditional output that's not colored, then hello world. If we want colored but modern, we get this, and then just normal. We default to hello world. Clause should contain fewer patterns. Pattern match is not exhaustive. 0, 1. What? Let's say 0, true or false. It's saying true and false isn't there? It totally is there. What do you do in ATS? Alright, I am JF, and I suck at ATS. I don't know why he thinks there's a problem here. 24, 28. It's true and false thinks it's not there, but it totally is there. Alright, we're just going to have to go and say, if you find that absurd situation, then just throw a runtime error. I don't believe you, though. So, hello, there. Say trad, then I get that. If I want colored, then I get that. And if I want color without the traditional, I get that. Alright, that's 3 versions of Hello World. Let's look at our final one again. So this involves a data view type, which is a linear type. There's memory allocation, but it's like ML style, like wrapper is around stuff. In this case, we have a wrapper around any kind of unboxed type, and we can say, yeah, it's either there or it's not there. We use this for, instead of using C's, instead of lying with C, where we had that resulted in a seg fault earlier, we immediately wrap C as getenv, so we still refer to it. By the way, there's no overhead with this particular function. It's not like we have like a wrapper that gets generated. Like, no, it's just the generated C code that ATS calls, which literally just refer to getenv or we refer to it. So in the code you'll be able to find like this function, and in that function it'll just say getenv. It won't do anything special. So there's no overhead there. There is overhead in the sense that like there's this function that's called and it returns it does some memory allocation to produce these linear types, which are then immediately consumed by is flag set, our wrapper for getenv opt, which is more like getenv bool. So what we could do is we just get rid of these optional types. In fact, let's do that. We're just going to be like horribly efficient for this tiny program. Alright. Only returning an optional view type, but a bool. There shouldn't be any overhead there, that's fine. Alright, false. Oh. It's null, isn't it? Let's do it like this. Oh. So we're going to do a comparison where... Alright. So this function is defined as this comparison. as this comparison of R. I'm going to say R is actually the getenv. All right. Hello 4. Although you can be much more, obviously you can be a lot more intelligent with how you use makefiles. You saw earlier I tried to like automatically generate like the list of files. You can do cool stuff. But the point is, like, even if you don't do, even if you're completely like Stone Age, like I'm going to create an entry for every single one, makefiles still give you so many benefits. Like I do like make clean, I make them all again. If I change it, I can just type make. I don't have to like remember the command or change the thing and type make. Like if I go to hello 4 and say actually I would say hello modern world in that case, that one case. Alright, so make again, it rebuilds it. So make files are actually quite good. Except look at this, I'm screwing up somehow. How did I do that? Okay, I want to have this be not. If it was returning true on false. Alright. Hello modern world. If I do it colorful, then it's not as modern anymore. Trad with that. Alright, I am JF, and this is the end of the first episode of I Suck at ATS. Please look forward to even more frustrating suckage than what you saw here.